Okie dokie. So it says, also notice that for a triangle centered in a unit circle, such as this figure 4.0.1, so this is like page 1. So if we have a triangle that looks like that with sides X, Y, and R, and I'm going to kind of sketch that out so you can see it. So let me sketch a little triangle where we have Well, actually, I'm going to go a little bit before that. So, and I'm going to kind of talk through this. So if you have a circle, if you have a circle and we're going to pretend like this keeps going around, if you have a circle and you have some point along the circle, it could be anywhere. I'm just putting it in the first quadrant. If I have a point right here along the unit circle, and to get to this point, I could get there one of two ways. I could go some value X and some value Y to get there. So some amount of X and some amount of Y. Or I could go straight there. And to get from the center to any point on the circle, what does that distance represent? Starts with an R. A radius. It also represents a radius in a circle. You're not wrong. It is also the hypotenuse. So with an angle, and we would say that the angle is right there. So this is like the picture that's on the front page, but that's like how you would draw the picture. If we said that the radius is 1, we said that the radius is 1. What would the relationship between X, Y, and R be? Well, the relationships of the sides of a triangle would be X squared plus Y squared equals R squared. But if we say that R is 1, then it'd be 1 squared, which is just 1. So that's where this comes from. That's very important. So it's kind of like if this, then this. So if we're looking at this picture, then this is true. And then this is something that we're going to start learning that if we were going to describe from this angle and we were going to do like sine, cosine, and tangent from that angle, X is adjacent. And so adjacent, does that go with sine or cosine? Adjacent, does it go with sine or cosine? Cosine. And so X goes with cosine. And from the central angle, that's called a central angle, across from it is Y, or opposite is Y. So Y goes with sine. So if X is equal to cosine and Y is equal to sine, then this is also true. So X and Y can be interchanged with sine and cosine. And this is extremely important because this is called the Pythagorean identity. Why do you think it's called the Pythagorean identity? It's built off of the Pythagorean theorem. Yes, it is now an identity. Okay, this is really important. So notation is important. Like last class when I said that angles are capital letters and side lengths are lowercase letters, notation is important. Kind of like when we did natural log and I said that it's ln, it's not a capital L, it's a lowercase l. That's why it looks like an I. This is very important. So when you square something, so the x is squared, Do you see how we put the square part right there and not on the outside? They're very different. So I'm going to like show you what they actually mean. So this one, sine squared, this one means sine, sine. Okay, this is sine squared. Just like if you had x squared, it's the same thing as x times x. This one, however, means sine theta theta. So this is where the angle is twice instead of the whole operation being twice. So they're different. So please make sure you put the square right after the function. It doesn't go after the angle. Okay. Continuing on. So on the back of your yellow sheet, we are going to make this chart. Yep. So this chart looks really overwhelming. However, we're going to make it piece by piece. So I'm just telling you so we can space it out. Don't start writing anything. All you're going to do is like partition out your paper. So partition it out and you can label this as tangent identities, reciprocal identities, and Pythagorean identities at the bottom. So however you want to do it, if you want to do it long way, it doesn't matter. We're going to make this chart. So now I'm going to clear this chart. So this is what you're making. What is this, Sick?
Professional audio and audio settings. I think that just means audio sounds.
Okay. It's saying that my throat hurts. Okay, so we should have our paper partitioned out. We're going to have tangent, reciprocal, and Pythagorean identities. First, we're going to start with tangent identities, but I'm going to come back to this page. So if we were talking about this angle right here, and we wanted to describe what is the tangent. Tangent of that angle. Tangent is opposite over adjacent, right? So for this triangle, what would it be? Yes, it would be y over x. Well, what did I say that x and y equal? Uh-huh. So isn't tangent equal to sine over cosine? Why, yes, it is. So that is the start of our tangent identities. So we're going to start with the tangent. And the theta part is not optional. On your homework, sometimes it's t, sometimes it's x, y, z, sometimes it's alpha, beta, theta. It doesn't matter. That angle piece isn't optional. You have to put it. So tangent of an angle is equal to sine over cosine. Cotangent. What's cotangent then? Cosine over sine. And the way that I remember this identity, which one goes on top? Cosine has, or sorry, cotangent has cosine on top. So cosine over sine. Because remember, reciprocal identities just flip upside down. From here, I'm not making anything new. All I'm doing is rewriting this a couple different ways. It's not going to make a lot of sense why we're making this chart until we actually use it. But what we're doing is making ourselves like a reference sheet to be able to solve problems. So it's really important. So from here, I could also bring cosine to this side. And if I did, I would have cosine times tangent is equal to sine. Again, I didn't make anything new. All I'm doing is rewriting this a different way. Does everybody see how I created that? Okay. I could also bring tangent over and divide by tangent. So cosine is equal to sine over tangent. Again, this is just a couple different ways to see the same thing because you never know how you're going to see it. I'm going to do the same thing with the cotangent. I could multiply by sine on the other side. So sine cotangent is equal to cosine. And then I could also bring the cotangent under here and divide. So sine is equal to cosine divided by cotangent. So if you can create this, you can create this. And if you can create either one of these, you could rearrange it. Identities. Well, we learned that if you have, and that's what we just did here. If you have tangent, you can flip this upside down to make cotangent. But technically, like the definition of a reciprocal is that you take whatever you have and you put it underneath one. So sine is 1 over cosecant. Oh, I forgot my angle. If I forget that, tell me. I'm not supposed to. We have cosine, which is equal to 1 over, which one goes with cosine? Secant. Okay, only one co. And then if I have tangent, it is 1 over cotangent. And it works the same the other way. So cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tangent. So again, reciprocals might be, you might see something like this and you can turn it into this. You can also use reciprocals as like taking what you have and flipping it upside down. Pythagorean identities, they're going to start with the Pythagorean identity, which is, and it doesn't matter which order you do it first. Sine squared plus cosine squared or cosine squared plus sine squared. I might interchange them because I never remember. It doesn't matter. It's just 1 squared plus the other squared equals 1. So sine squared plus cosine squared equals 1. That's how you start.
Just really quick, the little square over the front, yeah, right, or over the little theta. Does it matter, or should I have to?
It goes in between. It's squaring the function. So no, it's not over the angle. From here, the way that I create the chart underneath, what I'm going to do is I'm going to make two branches out the side, and then I'm going to make like one line down the middle. But my two branches out the side, the way that I'm going to create them is, and it doesn't matter which way that you go, because like you might need to recreate some of this chart on your test. So it's really important that you know how to create this. All I'm going to do is out either side, and again, it doesn't matter which one. Out one side, I'm going to divide by sine, and out one side, I'm going to divide by cosine squared. So again, it makes no difference which side. So out one side, I can divide by sine squared. And out this side, I could divide by cosine squared. If you create this chart and you do it opposite, it's not going to matter. So let's see what we come up with. Let's pretend that I divide sine squared divided by sine squared. What does that make? What's anything divided by itself?
1.
1. So this will be 1 plus, what's cosine divided by sine? Cosine divided by sine. Cotangent plus cotangent squared equals, what's 1 divided by sine squared? Cosecant. I'm going to do the same thing out the other direction, but I'm going to divide by cosine. What's sine divided by cosine? Tangent, so it has to be tangent squared. What's cosine squared divided by cosine squared? I did it opposite, but what's anything divided by itself? 1. What's 1 divided by cosine squared? Secant. So let me be a little bit clear. The Pythagorean identities chart that we're going to create, it only works if you are squared. It also works if you're to the 4th power. Like it has to be squared. These, you can square it, you can cube it, like you can do anything with these, or they could be to the 1st power. So these work with any power. Pythagorean identity only works with when it's squared. And to give you like an example of that, do y'all remember a 3, 4, 5 right triangle? Okay, it works only if you do 3 squared plus 4 squared will equal 5 squared. Does 3 plus 4 equal 5? No. So the Pythagorean theorem or identity does not work if you're not squared. So you can't you can't use this if it's 1 plus cotangent is not cosecant. It's only 1 plus cotangent squared equals cosecant squared. Okay, it only works if it's squared. From here, all we're going to do is the same thing that we did up here. We're just going to rewrite things. So if I had this, I could, and this is in no particular order, it's just me rearranging the equation. I could bring cotangent over, I could subtract it, and then I'd get 1 is equal to cosecant squared minus cotangent squared. So that's one way I could rewrite it. 1 equals cosecant squared minus cotangent squared. Okay, there's one way I could write it. What if I left cotangent but brought over the 1? So I could say cotangent is equal to cosecant, and I could bring over the 1 minus 1. So cotangent squared is equal to cosecant squared minus 1. That's another way I could write it. I could leave cotangent over here, and I could subtract cosecant. I could subtract the cosecant. And so cotangent squared minus cosecant is equal to -1. So all I did was take the top equation and rewrite it a couple different ways. Because a lot of the goal of what we're doing today is taking something that looks really ugly and complicated and making it look simpler. So that's part of the directions today is simplify. So would you agree that this is ugly and it simplifies into something really nice, -1? That's what we're doing today. We're finding ugly things and we're using our chart. Could I turn this into something better? Yes, this is more simple. That's the whole goal of today. Same thing with this. If I had sine over cosine, it is more simple to just call it tangent. If I have 1 over sine, it is more simple just to call it cosecant. So we're taking more complicated things and we're making it more simple. I'm going to do the same thing out this way in really no particular order. So here I could kind of go in this kind of same order. I could bring over the tangent and subtract it to the other side. So I get 1 equals secant squared minus tangent squared. What did I do next? Okay, I left the tangent and I could subtract the 1 to the other side. So tangent squared equals secant squared minus 1. And there will be times where you see stuff like that. Secant squared minus 1, and we'll turn it into tangent because it's more simple. And then last, I could subtract secant. So I have tangent minus secant equals -1. Straight down the middle. Straight down the middle, all we're doing is rewriting the Pythagorean identity. We're really just going to rewrite it 2 different ways. We're going to subtract sine to the other side, and then we'll subtract cosine to the other side. So if I subtract sine, so straight down the middle, I would get cosine squared theta is equal to 1 minus sine squared theta. And then if I do the other direction, not the other direction, if I subtract cosine, then I get sine squared is equal to 1 minus cosine. So this chart looked really scary before we wrote it down. Hopefully it's not so scary anymore. And hopefully you could possibly get to a point where you could recreate it yourself. Yes, do you think that you could sit through a couple of examples first? Okay. So keep this chart very handy. We're going to use it. And so what I'd like to ask you to do while we go through some of these examples, some of you are going to get it really fast, and some of you it might take a few more examples, but I promise that eventually it should start clicking and make more sense what we're doing. So we're going to do some problems through the homework. So looking at 412A, we're going to do a couple of the questions. And the directions say simplify to an expression involving a single trig function with no fractions. So we're going to take this. It currently has 2 trig functions, and we're going to simplify it into 1. The next one, it has fractions and 2. So the whole goal is to just simplify these into what it says. 1 single trig function with no fractions. And we're using that chart to help us. And I will tell you that if you are stuck and you have no idea where to start, this is almost a foolproof way to start. It's not always the fastest, but you can at least get started. The easiest way to do these a lot of times, if you don't have something that's a Pythagorean identity, that the quickest way is using that chart. But just changing things into terms of sine and cosine will help you get the ball rolling. So when I look at this first problem, I have something that's in terms of cosine. Good. Could I rewrite cosecant so that it was in terms of sine? There's an identity. Cosecant is the same thing as what that has a sign in it. Yes. So I'm going to change cosecant. So this is going to be 1 over sine, and you have to use a t because that's the variable that they're using for the angle. And anytime I introduce a fraction, I'm going to go ahead and rewrite cosine as a fraction. I can put it over 1. Okay. Well, if I multiplied this, I would end up with cosine over sine. So, and I don't care if you put these parentheses, it doesn't really matter. What's cosine over sine? Cotangent. Oh, not theta. Did I simplify to one trig function with no fractions? Then I'm done. It's not terrible. The next problem. So I'm going to use that same trick. I'm going to rewrite secant and tangent into terms of sine and cosine. So secant is the same thing as what? 1 over cosine. So, and this is going to turn out kind of crazy because it's going to be a fraction over a fraction. So I'm going to have 1 over cosine over, what's tangent? Sine over cosine. Okay, we're going to do this one problem the long way, and then after that, you're going to see a little trick. From here, anytime you divide by a fraction, do y'all remember keep it, change it, flip it? You multiply by the reciprocal. That's what you do when you divide by a fraction. So all of this turns into 1 over cosine times, I'm going to flip the bottom fraction, cosine over sine. Now I'm going to look for things that cancel. Remember, anything over itself cancels just down to 1. So what I have now, do you see that if I multiplied this out, I got cosine over cosine? Yep. So I'm just left with 1 over sine. What's 1 over sine? Yeah, it's cosecant. So this equals cosecant. Did I get it down to one trig function, no fractions? Done. So now I'm going to show you a trick. When we're at this part, you don't have to do this part. Whenever these two denominators match, you could have skipped that next step and just marked them out. And you're left with 1 over sine. So anytime you have a fraction inside of a fraction, if those denominators are the same, then it cancels out. Which means the same thing for the numerators, like if the numerators match. All right. The next problem. Anytime you see something squared and a 1, go check that chart. Is 1 minus sine squared on your chart? What is it? Okay, then I'm going to rewrite it. Cosine squared t. And sine is already in terms of sine. Sine squared t. What's cosine over sine? Cotangent. So I simplified it down to one term, no fractions. So anytime you see a 1 plus or minus something squared, go check that chart. Question number 8. We're going to have a couple more steps. First thing that I'm going to do is rewrite this all in terms of sine and cosine. Well, cosine's already in terms of cosine, so I'm going to leave it. Sine is already in terms of sine, so I'm going to leave it. But secant is not. So secant is what? 1 over cosine. So 1 over cosine t. And since I have that as a fraction, I'm going to make this a fraction too. Put it over 1. All over sine. And it is okay if we get to these more complicated problems and you're like, I wouldn't have thought to do that. Well, I get it. You're just learning. So I'm teaching you all these tricks right now. From here, I would like to put these together, but I can't combine fractions unless they have a like denominator. Y'all know that. So if I need a denominator to match, then I could just multiply this whole fraction by cosine over cosine to get a like denominator. So that's what I'm going to do. I'm going to multiply by cosine t over cosine t so that I get a like denominator. And so what I end up with, and I'll be able to combine them at that point. What's cosine times cosine?
Oh.
How many do I have? Cosine squared. So in the numerator, I'll have 1 minus cosine squared all over cosine. Remember, when you have like denominators, they just stay the same. You don't have 2 of them. And then, of course, this is still all over sine.
Oh.
Yep, it's getting a like denominator. So cosine times cosine is cosine squared, and this is cosine in the denominator. So they're like denominators, I can put them together. Oh, now I have a 1 and a trig function squared. Is that in my chart? By golly, it is. So what is 1 minus cosine squared? Huh? Sine squared, yep. So I have sine squared t over cosine t, and then it's all over. I could make it a fraction over a fraction if I needed to. Sine t, and it's over 1 technically. So like I said, anytime your numerators match up or your denominators match up, you can cancel stuff out. So do you see how I have a square and then I just have a single? So one of these can cancel. One of them can cancel. I can cancel out one of these. So now I'm just left with sine over cosine. Sine over cosine. Tangent. So we took something kind of ugly and complicated, and we simplified it down to one trig function with no fractions. Okay, we're good so far. Next, we're going to flip over the page and we're going to look at questions 12 and 14. I personally think that verify is easier than simplify. Like, I mean, yes, we knew where we wanted to go. One trig function, no fractions. But sometimes simplify doesn't mean that. And you'll notice on the homework for part 2, it says simplify, but sometimes it's not just one trig function with no fractions. When you verify, you're just trying to make the left side look like the right side. So you know what the answer should be. You're just trying to take the steps to get there. So let me just show you. So for question 12, I don't know what to do, so I see that my answers are sine and cosine. Okay, well, I'm going to change everything into terms of sine and cosine. That's going to be my first step. So I get 1 plus, what's cotangent? Mm-hmm. Actually, we're gonna do something different. So for this one, do you notice how we have one fraction here? Here we have two different terms. So anytime that I have one thing that's all together and the answer is split up, I need to split the fraction. And so to split the fraction, all I do is use the same denominator. So I'm going to have 1 over cosecant plus cotangent over cosecant. So I'm just splitting the fraction up. I'm not rewriting anything yet. So 1 over cosecant, and they're using alpha, plus cotangent alpha over cosecant alpha. Do not okay, I wasn't specific. Don't rewrite the equals part. We're only working on the left side. If you start working on both sides, turns into a really hot mess and it gets crazy. So all I'm doing is manipulating the left side to make it look like the right side. From here, what's 1 over cosecant? Sine. Hey, how about that? Because we want it to be sine. So, I mean, we're already done with that piece. So 1 over cosecant is sine. Cotangent over cosecant. I don't think that we have anything we wrote down on our chart. Okay, well, I'm not going to spend forever looking. One thing I can do is just rewrite both of these in terms of sine and cosine. So cotangent is the same as what? In terms of sine and cosine. Cosine over sine. Cosine alpha over sine alpha. Cosecant. Let's put that in terms of sine or cosine. One over sine. What happens when the denominators match? So I'm left with, hey, what am I left with? Yep. As soon as you make the left side look like the right side, I box them both and I check it because I just made them look the same. I verified. It's another word for that is proof. It's also a trig proof. We did it. For question 14, I am trying to turn this ugly fraction into this. Okay. Anytime I have a 1 and something squared, I'm going to check my chart. Is 1 plus tangent squared on your chart somewhere? What is it? Secant squared. So I get secant squared b, not whatever that was that I drew, b, over tangent squared b. Okay, well, I think that it will be best for me to change everything into terms of sine and cosine. If I'm stuck, that's pretty much my go-to. So secant is what? 1 over cosine squared. What's tangent? Sine squared over cosine squared. What happens when the denominators match? Cancel. So I am left with 1 over sine. I'm getting too fast. Sine squared b. What's 1 over sine? Cosecant. And that's what I wanted it to turn out to. So I just verified that this does in fact equal this. I proved that this equals this. Are y'all starting to get the hang of what we're doing? But wait, I have more. It's just more examples that I'm giving you so that you aren't completely lost. Yeah. Well, good thing that I'm recording this and that I posted these notes online. All right, Annabelle, here you go.
You just like, I felt really weird the rest of the
Oh, so actually.
All right, moving on. This is the next packet. So on this homework, if you want to mark out 17 through 20, those are challenge problems. Like I don't expect you guys to do those. So 17 through 20, mark them out. Everything else I expect you to do.
Can I go to the bathroom?
What?
Can I go to the bathroom?
This is the second homework. What is on the board right now is on the second homework.
My stomach hurts, miss. I think I'm going to lay off the orange here.
That would be a solid plan. So this is the second packet, and I don't have anything marked off for this. So second packet, let's go quick. For question number 4. Question number 4. I might not be sure where to start, so my go-to is always, let's change things into terms of sine and cosine. Sine is already sine. Cotangent. Cotangent is cosine over sine. What about cosecant? 1 over sine. All right, from here, do I have some things that can cancel? Yeah, so I have 2 sines up here and I have 2 down here. So take that and I am left with just cosine. Next problem, before I get ahead of myself, I can do nothing with 1 plus cotangent. It's not squared. So don't check your chart. You can't do anything with it. Unless it's squared, you can't do anything. So I'm going to try and split this into 2 fractions. So sometimes that helps. So I'm going to split it into 1 over cosecant plus cotangent over cosecant. Okay, well, what is 1 over cosecant? Sine. For the other piece, I don't know what to do with it, so I'm going to do what I always do, rewrite it in terms of sine and cosine. Cotangent has cosine on top, so cosine over sine. You're going to change everything in terms of sine and cosine. Cosecant is 1 over sine. Okay, that was helpful because now I have denominators that match up. What happens when denominators match up? They cancel. So I am left with cosine. So I get sine plus cosine. For this packet, it tells you in the back, this one doesn't give you steps. It gives you like what you should get to. Even though it says simplify, it does tell you where you should end. So if you're feeling like, well, this isn't just one term, I know. On this packet, it's not simplified to one term with no fraction. So The next problem, question 14. I'm gonna do it. From here, these I don't know what to do with, so I'm gonna rewrite them in terms of sine and cosine. What about this? I have a 1 and I have something squared. Is that an identity? What is it? What's secant squared minus 1? Tangent. So I'm going to say cosine over 1. Cosecant is the same thing as 1 over sine. And then secant squared minus 1 is tangent squared. I'm going to put it over 1. Okay. Well, what's tangent? Sine over cosine. So I could say cosine. And I could put these together if I wanted. Like this could be just one fraction. Cosine over sine. And then tangent is sine squared over cosine squared. So I've got some things that match up, but only one of them. So this can cancel one of these. This can cancel one of these. So one of these. One of these. And so I'm left with sine over cosine. What's sine over cosine? Tangent. Again, the goal is taking something ugly and complicated and simplifying it down to something more simple. Question 19. I am going to distribute, because why not? I'm going to distribute this in. So I get cotangent times tangent plus cotangent times cotangent, which is cotangent squared. Hello? Yeah, in just a few minutes. Yeah. I know, I don't know what to say. I'm the evil math teacher. Yeah, we're still doing notes. We're almost done. All right, love you. Bye. Okay, so from here, there is a very interesting property that happens, and I'm going to show it to you with something simple, not with trigonometry. So a simple thing. I'm going to multiply a reciprocal times itself. This is just side work. You don't have to write this down. I just want you to watch.
Hello, Miss Spencer.
Hello.
My mom, did she email to you?
Yes. She did.
I'm so frustrated about yesterday, cause yesterday I went to eat McDonald's, right? I wanted the Grinch Happy Meal,
Oh, I've
But-
been seeing that.
they said that you have to be 18 to get the Grinch.
You have to be
Happy Meal.
under 18 or
No,
over
you
18?
have to be over 18, and
Has
then
anybody- See.
yeah, and then I said I want the Grinch Happy Meal, but they said let me see your ID.
What? It's crazy. I've been seeing them all over. Has anybody else tried to get one? Thank you
friend-
so much. This is so kind.
Yeah,
Well, I hope you get it.
yeah,
You'll have to go back to see if you can get it.
yeah,
And you look like you're feeling much better today.
yeah.
Good. I'll see you tomorrow.
Alrighty. When we have a test on Monday, right? Monday or Tuesday?
Monday.
No.
No, Tuesday. You're right. Tuesday, you're right. Okay, I'm going to show you this property. So I'm just going to pick a random fraction, 4/3, and I'm going to multiply it by its reciprocal, 3/4. And so if we multiply it across, 4 times 3 is 12. 3 times 4 is 12. What does that equal? Anytime you multiply something times its reciprocal, it equals 1. So what is cotangent times tangent? 1, they're reciprocals. Tangent and cotangent are reciprocals. So it just turns into 1. You could turn it into terms of sine and cosine and see that. Or if you wrote this as 1/tangent, then you could also see that it cancels just to 1. So that part is 1 plus cotangent squared. What's 1 plus cotangent squared? Cosecant? Beautiful. Okay, I guess I'll stop there. I was gonna do these next ones with you, but guess what? They're posted online, so you're just gonna have to watch, and this is my work to do them.
Okay,
So,
thank you.
we'll stop there, and then I guess I had this on the slides, but I already taught this to you last time. So the stuff that I have posted online, I guess, has this on there, but I feel like this is day 1 stuff. I don't think we need this yet for anything you're doing today. So you should be able to do the homework, the both days of homework, and it's really just going to take grit.